By bringing two resistors in series together, we form a voltage divider circuit, and at their midpoint we get our output. With this 220k and 1 mega ohms resistor, you can see we have 5 volt at its output and our power source is 7 volt. So in this video, I'm going to show you how and where to apply voltage dividers, or using them as sensors or reference voltage to a circuit. So with further ado, stay with me for the rest of this video. Here we have two resistors in series, R1 and R2, and our power source is 7 volt. So for the voltage divider to give a voltage less than our power source, R2 must be greater than R1 value. But if you need something more less than half the power supply, R1 must be greater than R2, and that output will be around 0 to 1.5 volt in some cases, depending on your value of resistors. But if you need half of our power supply, then R1 and R2 should be identical. I am choosing 10k, and for it's my favorite. And without a meter, you can still tell what your output voltage will be by using this formula. Your input voltage multiplied by R2 divided by R1 plus R2, or your input voltage divided by R1 plus R2 multiplied by R2. Whichever you think is easy for you to remember. Let me know what you think in the comment section below. We can see them used in the internal structure of a 5-5 timer. 3 identical resistors, but don't think their output are going to be the same because I said so. You may be misleading yourself. These 3 identical resistors act as a reference voltage for the 2 comparators, and at this point, remember, if 2 resistors are connected in series, their values adds up. So they aren't identical in value, but in bands. To find their output here, the formula for output 1 will be the input voltage multiplied by R2 will add up with R3 and divide by R1 plus R2 plus R3. And for output 2 will be R3 divided by R1 plus R2 plus R3 multiplied by your input voltage. Output 1 will be second third of VCC, and output 2 will be 1/3 of VCC. So have you now known why I said you will be the one misleading yourself? Here is an IRF-Z44N, an N-channel Mosfet. Let's see how we can use this to turn on a Mosfet transistor. To check what voltage is needed to turn on the Mosfet from its manufacturer datasheet, you can check sites like All Datasheets. For this is where I check most of my transistors and IC datasheet. We can see that to turn on the Mosfet, we need 2 volts up. But if not up to 2 volts, the Mosfet will remain stubborn and not turn on. So I will make R2 1 mega ohms and R1 220 kilo ohms. If you do your calculation well, you should have 5.7 at its output. So in that case, do you think this can turn on the Mosfet? Be the first to say yes or no in the comment section below. This helps me to know you are really following this video and you are not left behind. So if your answer is no or yes, let's see if that's true or false. So I take our resistors values and form a voltage divider between the gate to source voltage, and added a current limiting resistor to our LED to the drain leads, and send in our power supply, and you can see the LED illuminate. So you will be correct if you said yes, but if I swap the resistors, let's see what happens. You can see our LED is now off. That's because I made R1 value greater than R2, and from the voltage divider formula we get 1.3 at its gate, and this is not the required voltage for our Mosfet according to the manufacturer datasheet. Okay, with 2 identical 10Ks, we get half our power supply. which should be 3.5 at the gate. We can also use variable resistor to form a voltage divider, so it can easily be adjusted and you can see two resistors in one. So we get our output voltage at the middle leads. But I choose to use this other one. Now we see our LED is off. So watch as I do the adjusting and let's see when the LED will come on. This is an LDR, known as a light dependent resistor, which means it depends on light. So this is going to be adjusted by light automatically. That's why it's called a light dependent resistor. So its resistance will drop when there is light in the room, but increases when it's dark in the room. Okay, now we have our LDR, everything set as a voltage divider. But you will notice our Mosfet is in the cutoff state, which is supposed to turn on the LED. It's because I made R1 value greater than R2 value. But how? Can someone tell me why? It's because we have light in the room and R2 resistance value has dropped below R1. So that's why R1 takes the advantage of that. And we have 0 voltage at the gate. But if R2 value goes high or greater than R1, the gate will be turned on. So you have now known how a street light works. Simple, and can build one yourself, and that's great. And from this little demonstration, you can see how this works. Each time I block the light from the LDR, the LED turns on when the gate is open. Okay. What we have here is a thermistor. Its resistance changes according to the temperature around it. So its resistance increases when the temperature decreases and decreases when the temperature increases. And with a soldering iron demonstration, you can see the light coming on each time it gets hotter. So with this demonstration, I think by now you have now know how to build a temperature detector yourself. Voltage dividers are also used for reference voltage in op-amps. To learn more of that and how to use op-amps, check for this other video I have made out for you. Video link and other links to other videos, check below the description box. Okay, don't forget to share, subscribe to this channel for more video coming to you next time. And let me know in the comment section what you have learned and what other project you could use voltage dividers for.